On homework 5.8, you are practicing with rational and imaginary expressions. The key ideas here are that we combine like terms and we simplify using algebra rules. I'll help you with a few of them. Number 3 asks us to do this guy. The first thing I'm going to see here is that there's this minus this binomial. I'm going to go ahead and distribute this and rewrite negative 6 plus 7i. We are subtracting both this and this, so plus 7 minus I plus 8 minus 6i. We combine our real part first, negative 6 plus 7 plus 8. So it's 15 minus 6 is 9, so we get 9. Then we can combine our imaginary part. Our imaginary part is 7i minus 6i. 7i minus I is 6i. 6i minus 6i is 0. So the answer is just 9. There is no imaginary portion. Usually we put our real part plus the imaginary part at the end. Okay. Let's look at a, well, I guess we should do one of these real quick. Let's look at one of these imaginary ones where we have to multiply. This is a binomial times a binomial. We should know from Algebra 1 that the first term will distribute. 4 times 5 is 20. 4 times 7i is 28i. Negative 2i times 5 is negative 10i. And then the last thing is negative 2i times 7i. Well, negative 2 times 7 is negative 14. I times I is I squared. And this is the key difference between having a variable there and the number I. I is the square root of negative 1. So when we do I times I, that's negative 1. I squared is negative 1. So instead of writing negative 14 times I squared, it's negative 14 times negative 1, which is a real part. Negative 14 times negative 1 is positive 14. 20 plus 14 is 34. 28i minus 10i is 18i. So we get 34 plus 18i. Okay. Let's go into the irrational ones. And we'll look at some, I'll look at number 10 because I think it's a little bit tricky. On number 10, well, we got these that can combine. They're both square root of 24. Oh, that's not as tricky as I wanted it to be. There was a trick I was hoping was going to be there. It was not there. We're going to go on to number 24. This one's too easy. You can do it on your own. Number 12. This one has the trick I was hoping was the last one. Notice there are no like terms. But we have a couple things we can simplify. This square root and this square root can both be simplified because there are square numbers that go into them. I'm going to rewrite this one as it was, but this square root can be rewritten as 4 goes into 20, and 4 is a square number. So it's the square root of 4 times the square root of 5 gives you the square root of 20. And over here we get minus 3. 4 also goes into 24, so minus 3 times the square root of 4 times the square root of 6. And we can do these square roots of 4. It's negative 3 square root of 5 minus the square root of 4 is 2. 2 square root of 5 minus 3 times 2 times the square root of 6. If you just write the 2 and don't put parentheses here or put a times sign, it looks like 32, and that's not right. Negative 3 was multiplying times the square root of 4, so now negative 3 is multiplying times 2. Now we have some like terms we can combine. Negative 3 square roots of 5 minus 2 square root of 5 is very similar to if we have negative 3x minus 2x. It's negative 5x. This is the type of thing it is. This coefficient tells you how many there are. There are negative 5 square roots of 5 minus, here we can do 3 times 2, 6 square root of 6. Hopefully that's helpful. We'll do number 16, I think. Here we have square root of 2 plus 2 square root of 3 squared. I'm going to use the square binomial shortcut. We square the first one, and the square root and the squared cancel out and give me 2. That's because square root of 2 times square root of 2 is the square root of 4. You can multiply what's on the inside, but the square root of 4 is just 2. This will always happen if it's the same number. Square root of 2 squared, the square root and the squared cancel out and just give you 2. So we square the first one, we multiply these two together and double it. Well, the way we multiply is you're allowed to multiply a square root times another square root. To combine it, it'll be the square root of 6 times the 2. 2 square root of 6 doubled will be 4 square root of 6. So we multiplied them together and got 2 square root of 6 times 2 is 4 square root of 6. Plus, we're going to square the last one. So it's 2 square root of 3 times 2 square root of 3. There's a rule for squaring a whole number times a radical, which is that you just square both of them, because you can just multiply in a different order. 2 times 2 is 2 squared. Square root of 3 times square root of 3 is square root of 3 squared. So you get 4, and the square root of 3 squared is just 3. So when I look at this, what I think is 2 square root of 3 times 2 square root of 3. This is not a binomial. We don't have to do any sort of trick on it. It's just 4 times 3. 2 times 2 is 4. Square root of 3 times square root of 3 is 3. 4 times 3 is 12. The last thing is we can combine our terms. I hope you notice that the pluses are what's separating terms. So 2 plus 12 is 14. 4 times the square root of 6 is a separate term, and that is all we can do to simplify it. Okay. Let's move on to a radical one, where we need to simplify the denominator. You are not allowed to leave square roots in a denominator. It is not simplified. So what we do is we multiply by the square root of 3 over the square root of 3, because square root of 3 times square root of 3 will be square root of 9, which is 3, or you could think of it as square root of 3 squared is 3. Here, 4 square root of 2 times square root of 3, you can multiply the square roots together and you get 4 square root of 6. So that's what this is equal to, is 4 square root of 6 over 3. That is the simplified form. Notice on this next one, we cannot just multiply by the square root of 2, because this is a binomial, and the square root of 2 would distribute, and we would still end up with a square root in the denominator. Instead, we use a trick called multiplying by the conjugate. And multiplying by the conjugate just says if you have a plus b, you multiply by a minus b. If you have a minus b, you multiply by a plus b. And the reason this works, we have to do it on both the numerator and the denominator. The reason we're allowed to multiply by the same thing in the numerator and the denominator is when I divide this divided by this, it's the same thing. So anything divided by itself is 1. We're just multiplying by 1. And multiplying by 1 doesn't change the value of something. So we're allowed to do this. So let's see what we've got. In the numerator, we have a monomial times a binomial. So we need to put parentheses here, so the square root of 2 will multiply times both. When we do that, square root of 2 times 2 is 2 square root of 2. Square root of 2 times square root of 2, square root of 2 squared, square root of 2 times square root of 2 is just 2. Divided by, in the denominator, we have a binomial times a binomial. So we're going to put parentheses around both of them. And the reason this trick works is we'll get 2 times 2, which is 4. And then this next part is kind of magical. What's going to happen is we've got 2 times the square root of 2. So we get 2 square root of 2. And then the next term is going to distribute. Square root of 2 is going to multiply here, but this one is a negative. Negative square root of 2 times 2 is negative 2 square root of 2. And that's 0. So we're not even going to write it. Instead, when we have when we multiply by a conjugate, it's just a squared minus b squared. And square root of 2 times square root of 2 is just 2. Notice that there are no square roots in the denominator because they canceled out right here. So this is equal to, I usually write the whole number before the square root, 2 plus 2 square root of 2, all divided by 2. Now, this divides evenly. This is a binomial. I can factor out the 2 and get 1 plus the square root of 2, because 2 times 1 is 2, 2 times square root of 2 is 2 square root of 2, all over 2, and then this factor will cancel. And so my final answer is just 1 plus the square root of 2. Okay, one more problem. That's all I have time for. Well, I guess I can do 2, but I'm frustrated by it. You also aren't allowed to leave, imaginary numbers in the denominator, and so we need to get this I out of the denominator. Well, This is pretty easy because the way to turn I into a real number is you just multiply by another I, because I times I is -1. So that's what we're going to do. We're going to multiply by I over I. Again, this is just a fancy version of 1, so we're multiplying by 1 and not changing anything. The numerator will be 9I. The denominator will be 4I times I is 4I squared. I squared is -1. So the 4 times -1, which is -4. Now, we usually don't leave negatives in the denominator. A positive divided by a negative is a negative. So -9I divided by 4. You can either put the negative in the numerator or out in front. Either way is okay. Similar to our radicals, we can't leave i's in the denominator even when there's a binomial. We can't just multiply by I because there's a binomial, and so if we multiplied by I, this would turn real, but this one would be 3 times I, which would be imaginary. So we're going to use our conjugate trick again. So if we put A plus BI, we multiply by A minus BI. So we're going to multiply by 3 minus 8I. This is called multiplying by the conjugate. And so we need to multiply by the same thing on top. That way we're just multiplying by 1. This is a monomial times a binomial because they're separated by this minus. So we need to put a parenthesis here and distribute. 3 times 3 is 9. 3 times -8I is -24I. Divided by, in the denominator, because we're multiplying by the conjugate, again, 3 times 3 is 9. We're going to get -24I plus 24I, and those middle terms will cancel out. And so the last thing we need to do is multiply 8I by -8I. And 8 times -8 is -64. But I times I is I squared, which is -1. And so we'll end up with -64 times -1, which is positive 64. So our answer is 9 minus 24I divided by 9 plus 64 is 73. We can leave it like that. We can also, oftentimes we'll rewrite in A plus BI form. You can rewrite this as 9 73rds minus 24 73rds I. Either one of these is fine. All right, I hope that helps. Good luck on the rest.